Okay, great. Thank you for the introduction, and thank you for inviting me to this meetup. Actually, it's my first time to this meetup group, and I've never met any one of you. But so I don't actually, to be honest, I don't know the background of the audience. This slide I prepared is more from academic perspective because I'm more focused on the research. So if you have any questions, please feel free to interrupt me, or you can just leave any comments in the chat box. I'm very happy to answer your questions. I will present this slides, and after the presentation, I will I will also demonstrate a little bit about how you can use this model to extract information from financial text. Okay, let's get started. So let's talk about some background. Again, I'm a researcher. Well, by the way, I need to introduce myself. My name is Yi Yang, and I'm an assistant professor at HKUST Business School in the Department of Information System. My background is machine learning and NLP, and how it's being applied in management science related research. So that's my background. And why I'm getting interested in this research, in this topic, because there's a lot of interest about analyzing financial data, financial textual data in finance and accounting research. If you look at the recent progress in the finance and accounting literature in the past few years, you will see a large number of papers have been tried to see whether they can use financial text signals to predict either maybe stock return or stock volatility, or maybe even to see whether there could be some corporate fraudulent indication. So there's a lot of information embedded in this financial text. However, most of this research, they rely on very simple NLP methods, such as the bag-of-words model. In the bag-of-words model, you just treat each word independently. And if you have any previous experience in dealing with financial data, there's a very famous, well-known lexicon called LM Dictionary, which is something that I had highlighted here. So this is a dictionary approach. Basically, the L and M. Basically this L and M dictionary is widely used in financial studies. In this lexicon, they have a list of words that are being labeled as positive words, and have a list of words being labeled as negative words, as well as some other categories, so that the researchers, finance and accounting researchers, can use this lexicon to simply count the positive words, the negative words in the either 10K documents or on conference call analysis reports. So this is a very simple approach. However, it's very effective. This is a very effective method because this dictionary is being developed manually by domain experts, two well-known finance professors. Based on those techniques, based on these lexicons, there are some other approaches being proposed to analyze the information, analyze the textual data, financial text data. However, still, I would say most of the research is rely on very shallow machine learning models, bag-of-words model running using naive Bayes model or logistic regression model. It's a very simple model. Recently, we know there's some huge breakthrough in NLP, that is embedding model. There are different kinds of embedding model. The traditional embedding model, which was proposed in 2013 by Mikolov, the word-to-vec model, is a very famous model, where each word is being represented by a high-dimensional vectors. And later on, we have some pre-trained language model, where the words being represented where the words being represented not by static word embedding model, embedding, but by it depends on the contextual information. So that's called contextual embedding. So there are some language models being proposed, such as the Elmo, the OpenAI's GPT-2, GPT-3, and we also have the very famous BERT model. However, those models, contextualized word embedding models such as BERT, Elmo, GPT, they are trained on genetic text documents, general text. How does this language model being transferred to finance domain? That's a question that we don't know. And there's some research showing that by incorporating the domain-specific knowledge, such as LM dictionary, we can improve the model's performance on a specific domain. So which motivates us to try to train a BERT model for finance text, finance domain-specific BERT model. However, training those models is costly. There's no existing models that is available in the finance domain. And we don't know, before we train the model, we actually don't know whether this model can actually improve our research or analyze those financial text data. For example, let me give you an example. Let's say BERT, right? We know that BERT is state-of-the-art model. However, there's some restrictions or constraints in terms of a document length. For example, 512 tokens. If you are familiar with BERT, this is the constraint you have to deal with. Many of these financial data are very long, way more than 512 tokens. In that case, how can we directly apply the BERT model to this long text? That is the question. And also, again, as I said, the BERT model is not trained on finance data, but trained on general text data, Wikipedia. So the question still, we don't know whether those powerful NLP model can give us some utilities in terms of analyzing financial data. And in this research, we want to quantify this new NLP approach and compare it against previous text analysis approach being widely adopted in finance accounting research, such as the lexicon-based bag of words model. So that's our research question. Well, I have before I go into the to introduce the FinBERT model, the finance domain-specific model. Let me briefly talk about the word embedding model in case you are from non-NLP background. So basically, traditional way of representing the words is the very famous, very popular, and very easy one-hot encoding, where we use a dummy vector to represent a word. And later on, there are some word embedding models to represent the word with high-dimensional vectors, such as 300 dimensions, 100 dimensions. And the idea is that the words that are semantically and syntactically similar will have similar word embeddings. The problem with word embeddings, the word embedding is good in terms because it actually squeezes a lot of information in this 100 and 300 dimension space. Compared to the previous research, compared to the previous one-hot encoding model, these word embedding models can usually improve the downstream tasks in terms of sentiment analysis, document classification, name entity recognition. And to train the word embedding models, we have people propose different objective functions. For example, the word-to-vector model, their objective function is to predict the surrounding words, even the focal words. So you can say that this is a very difficult task, right? Giving a vocal word, how can you predict the surrounding words? But by training this model on large amount of data, the words that are semantically and syntactically similar will have similar word embeddings. For example, if you look at the word bank in this low-dimensional space, word embedding space, it will have vectors. The word embedding of a bank will be close to the word river, because sometimes people talk about a river bank. And also it's close to the word checking, because checking account is sometimes being mentioned in the context where the bank is also being mentioned. So the result is that the words like a bank have vectors close to both river and checking. Well, the problem, you can see that you may wonder, how does one word that is similar to either river or checking, because we hope that the meaning of the words, it really depends on the context of the words. So that is a limitation of the traditional word embedding model. And now we have this contextual word embedding model, the BERT model, the Google's BERT model, and as well as some other models that have been proposed in the last few years. The idea of this model is very similar to the traditional word embedding model. That is to represent a word. That is to represent a word in a low-dimensional space. Use a vector. However, the numbers in the vector is determined by the surrounding words of that word in the sentence. In that being said, the word bank, the embedding of the word bank will have different word embeddings in the following two different sentences. I went to the bank to deposit a check, or I walk along the river bank. Both sentences have the word bank, but their vectors will have different embeddings. So this is called contextualized word embedding. So I'd like to pause a little bit. Do you have any questions about word embedding or BERT in general? Or any questions?
So far, no. So basically, if there are questions, people can write in the chat and we may go through them at the end of the talk, if it's fine for you.
But, good. Okay, that's good.
So far, it has been quite clear, I think. Thanks, Leon.
Okay, that's good. Yeah. So yeah, if you guys have a background in machine learning or NLP, I think the past few slides you can just skip it. That's very basic. The state-of-art model, is BERT model or the GPT model. Depends on whether you have access to the GPT-3. If you don't use BERT model, word embedding model is the basic building block for many of the NLP tasks. I cannot think of any application right now that does not use word embedding, to be fair. Yeah, so that's recent advance in textual analysis. But as I said, the BERT model is trained on general documents, Wikipedia, and book corpus. In finance and accounting, those financial documents, have some different words, different meanings. So we want to capture this nuance. Therefore, in this paper, the FinBERT paper, we pre-train the BERT model for using financial communication documents. So you may wonder, what's your contribution here? To be honest, the novelty, the credit all goes to BERT. Who goes to BERT? They train the BERT model, they release their code. We simply use their code and train another BERT model on our own financial documents. I would say training these models using our own documents, financial documents, could be considered as a contribution. Also, we also evaluate these models against BERT model and against the traditional dictionary-based approaches and see whether or not the FinBERT model can better understand financial text. The paper is on this link, and we also have a code base on GitHub where you can use the models. And we also provide a Jupyter notebook on GitHub so that you can try these models on your own documents and see whether that model is accurate. To sum up, in this work, which we will talk about later, we pre-train this BERT model using financial corpora. And to give you some quick summary, for the downstream prediction task, like sentiment analysis, FinBERT is more accurate than the vanilla BERT model. For empirical analysis, we found that the sentiment, the tone derived from FinBERT has an advantage in predicting market reactions, returns and trading volumes, future firm fundamentals, and other metrics than BERT and this dictionary-based approach, M approach. Let me give you a little bit of details about the FinBERT model. So what is our corpus? Well, the FinBERT model is trained on the following 3 corpus. The first one is the corporate report 10K and 10Q, which in total contains 2.5 billion tokens. The second data set we have is earnings conference call quantitative data set, which itself has 1.3 billion. We also have an analyst report data set, which has 1.1 billion tokens. The analyst report data set is from SP 500 firms during the year between 1995 to 2012. The year after, we don't have access, so we don't have that analyst report. The total number of tokens that are being used to train the FinBERT model is 4.9. To give you a comparison, I think if I remember this number correctly, the BERT model is trained on the corpus with about 3.3 billion tokens. So that being said, our data set has way more tokens than BERT models, training data set. And in order to, again, as we know that the financial texts have different vocabulary, use different words, have different traditions, language use, right? So we also want to, instead of using BERT's base vocabulary, we want to use our own vocabulary. We have 2 vocabularies, the FinVocab, the cased version and uncased version. Why? Because in some applications, maybe you want to use cased vocabulary. For example, in the name entity recognition, maybe the capitalized word has more information for this task. Therefore, you want to use cased vocabulary. For some document classification, sentiment analysis, maybe you want to use uncased model. We also compare this vocabulary with Google's BERT's base vocabulary. We found that there's only 41% overlap between base vocab of BERT and FinVocab. So that is the details of our data set. We follow the BERT's GitHub code base to train the model. We have we train 4 models. Based on how the vocabulary is used, which vocabulary is used, base vocab versus FinVocab. Also based on whether the vocabulary is a case or uncased, we have 2x2 case. So we have, if we are training the FinBERT from scratch using the FinVocab, the case version, that is FinVocab case model. However, you can also pre-train, this is what we call further pre-train the BERT model using the BERT base vocab. So you use the exact vocabulary as Google's BERT. You further train with these 4.9 billion tokens, financial tokens. Yeah, the learning rate or the training step, the details are here. We actually follow the suggestions in the Google's BERT paper. We also monitor the loss, the training loss to make sure that we do not mess it up. Training those models is quite expensive, as you can imagine. We use a multi-core GPU. It contains 4 GPU cores. It takes about 2 days for pre-training one model.
So just a quick question. Is that some deep learning rigs that are available at HKUST, or how did you manage to set up this framework to train FinBERT?
We have our own server, GPU server. So we use our own GPU server to train the model.
And this Rover framework, I'm not familiar with it. Is it easy to use?
Oh, okay.
Did you learn the thing, or you have like a team?
The framework you mentioned is this Rover framework for multiple GPU training?
Yeah.
Okay, this is not us. This framework is actually a multi-GPU training framework released by Uber. So if you Google Rover, you will find it on GitHub. I think that's released by Google, Uber. So this is a pretty good parallel training framework, which we leverage. Okay, so basically we stand on the shoulder of the giants. All we have done, is to compile this textual data set, financial data set, and do some downstream analysis. Well, let me show you some results here. The first result I want to show is that the sentiment classification. As we know that the financial sentiment classification is one of the important tasks because the sentiment can be a very good trading signals. And many companies, financial institutions, hedge funds, they are actually monitor the market sentiments, which is in the form of social media discussion, analyst reports, etc. So if we have a very accurate sentiment classification model, that'd be good, right? Because that means that the sentiment signals will be more accurate. We evaluate the performance of the BERT model, the FinBERT model, on 3 different financial sentiment classification data sets. 2 of them is publicly available. The financial phase bank is publicly available. The FIQA data set is also available, public available. The last one, the analyst tone, is our own data set, which was annotated manually by us. It contains about 10,000 sentences from analyst reports. So we manually annotated this data set. Yeah.
Sorry, did you release it that open source, this data set, or not?
The first 2, the financial phase bank and the FIQA data set is publicly available. The analyst tone data set is not publicly available yet.
Okay. Okay.
Yeah. Just to give you a quick result, the result shows that the FinBERT is better than BERT in terms of sentiment classification, so it's more accurate than BERT, which is not that surprising because our model is actually trained on financial data sets using financial vocabulary. So you would expect that this model actually capture more of the nuance in the way of people talk, communicate in the corporate context. We also find that the fin vocab is better than base vocab, which is also not surprising, right? We also find that the on-case model is better than case model. So that's the 3 takeaways. So this is the first result. Let me show you another analysis, which I think is more interesting. well, the sentiment analysis is a standard machine learning task, but in this next empirical test, we are trying to see whether the sentiment derived from FinBERT can better predict the firm's future returns, trading volumes, compared to existing state-of-the-art methods such as BERT and LM dictionary. So this is how we set up our empirical test. We used about 18,000 earnings conference call transcript from the routers database. Because we already trained our data set, right? We already have a FinBERT model. We fine-tuned the FinBERT model using analyst tone data set, which was manually annotated by us. So we trained the FinBERT. We also fine-tuned the FinBERT on our analyst tone data sets. We then apply this already fine-tuned model on this 18,000 transcripts. And we calculate the sentence level sentiments. Does that make sense? So basically, for one earnings conference call, we we actually segment the transcript into different sentences, and we will apply FinBERT, the fine-tune of FinBERT on each sentences, and we get a sentiment. So I have a question from the host that says, did you use Snorkel to label your data? No, I did not use this labeling framework because it's only 10,000 sentences. It's not like an industry level data annotation. So we are still researchers. We are not using this fancy framework to label the data.
Okay.
To just give you some sense, we found that the FinBERT models, again, in terms of the estimating the sentiment, is more consistent with the human labels, and it's better than the lexicon-based LM dictionary. So let me tell you how the LM actually calculates the sentiment of earnings conference call. Basically, it will just simply count the number of positive words and the number of negative words. That's it. The difference between the positive words and negative words will be considered. If the number is greater than 0, that's a positive. Otherwise, the tone of the transcript will be positive. Otherwise, it will be negative. Okay. So this is very simply the word matching methods. But that is widely used, by the way. Okay, so here we are trying to use our FinBERT derived tone. So what is tone? Tone actually is the difference between positive and negative words in a conference transcript. So each transcript will have a tone number. Okay, the higher the number, the more positive the tone is. Okay, if the number is negative, it means that the tone of that transcript and its conference call transcript is negative. Our dependent variable is the first two, the CAR and abnormal volume. CAR means the cumulative abnormal return, which is the standard way of calculating the return. The abnormal volume is just the volume, trading volumes. We actually, because our goal is to compare the tone derived from FinBERT against existing methods. So we compare against the tone of BERT, tone of LM dictionary, and the tone derived using the naive-Bayes as well as word-to-vect, the word-to-vect model. This slide shows the correlation between the tone derived from different methods. We see that the FinBERT tone is highly correlated with the BERT tone, which is not surprising. Okay, so here this table shows you the predict power of different tone measure on the dependent variable CAR, the abnormal return, where we control the earnings, a lot of market numbers, and also firm fundamentals. If you look at the number here, you can see that, okay, so all these 5 measures, tone measures, are significantly and statistically correlated with the CAR, meaning that all of those tone measures can somehow predict the abnormal return. But which one is better? in predicting return? Well, the result is that the FinBERT model have a higher correlation, statistical correlation, which means that the FinBERT model is more correlated with the abnormal return. So it can better explain the abnormal return of the firm. We also change the dependent variable to the abnormal volume, which we want to measure whether the our FinBERT, the sentiment that derived from FinBERT can better predict the abnormal volumes. And we show that okay, the FinBERT model have a more statistically and significantly correlated with the abnormal volume compared against other methods. So the takeaway is that if you want to derive a sentiment signals from the NS conference call, you better use FinBERT, because that one can better gauge the sentiment in the NS conference call transcripts. That question says, is the precision of the signal the same for positive and negative news? Oh, that's great. That's a great question. So you can see that here, the dependent variable is abnormal volume. We don't use the tone here because the prior research shows that abnormal volume is correlated with positive news and negative news. So if you look at the table here, I would say no, the signal, the strength of the signal is different. The correlation is different. So if you look at the number here, the positive sentiment derived from FinBERT is 0.448. That's the statistical coefficient, while the negative coefficient is 0.422. So it's different. But if you compare, what I really want to highlight is that if you really want to compare the coefficients of FinBERT against other methods, the higher the coefficient, the better at predicting the future return, abnormal return and abnormal trading volume. So I have some other cross-sectional analysis, but that will be too detailed. I'll just stop here. Let me briefly summarize what this work is about. So we have done two things. The first is that we train a BERT model using financial text data. Later, we show that this finance BERT model, FinBERT model, which we call it, has better sentiment classification performance than traditional BERT model and other word-to-vector model. Also, we show that this FinBERT model derived tone and sentiment can better at predicting the firm's abnormal return as well as abnormal trading volume. So our contribution is that it's the first to introduce the BERT and the finance BERT to the finance and accounting studies. And we actually open source the code. We also quantify the benefits of using BERT and the finance BERT with economics magnitudes. So that's our major contribution. Let me briefly show you what the GitHub repo look like. Just give me a second. Yeah. Okay, so this is the FinBERT repo, which we release the model. Not only do we release the FinBERT model, but also we also release the fine-tuned FinBERT model. If you remember, we fine-tuned the FinBERT on these 10,000 analyst tone datasets. So you can feel free to use that if you have sentiment classification tasks on your desk. We also provide a Jupyter notebook where you can just very easily enter your sentences, financial sentences, and the notebook will output the sentiments of the sentences. I'm not going to run a demo here because my computer is not connected to the server, but you can see that we actually contains all the details codes here. So let me show you here. So we have three sentiments: the neutral, the positive, and negative. The index here is a little bit strange. We use 0 as neutral, 1 as positive, and 2 as negative. This is just how we did our annotation. We have three sentences here. This is a shortage of capital, and we need actual finance. Blah blah blah. We have three sentences. We upload the model. The model, the FinBERT model, will output the returns. Sorry, we have four sentences. Four sentences here. The model will give you the output. Not only will give you the output, actually, it will also give you the logics. So you can the probability, which you can use, in some applications. Yeah, so that's pretty much all I have for this work.